Today we're going to be using the derivatives to sketch our function, and we're going to be looking really at what the derivatives mean in relation to our original function. Okay, so our first example here, we're given our derivative, and we need to identify where the extreme of f occur, the intervals of increasing and decreasing, where we're concave up and concave down, and then sketch a possible graph. Now I have a dual page display on because I'm going to be needing a lot of room. Okay, so for A, okay, our extreme occur when our derivative equals 0. So I set our derivative equal to 0. And then I factor. And our critical points are 0 and 3. So on my little number line, again, we're going to be looking at our sign of our derivative at 0 and at 3. So now what we're going to do is we're going to kind of look and see, okay, number line like we've been doing, so numbers less than 0, that first 8x squared is always going to be positive. So this second piece is going to be negative. So we're decreasing from 0 to 3. The x squared is still always positive, so I'm looking at that x minus 3. If I plug in 2, I'm still negative. Then for greater than 3, we change to positive, so we change to increasing. So identify where extreme occur. At 3, we go from decreasing to increasing, so that's going to be a min. We are going to have a min at x equals 3 because f prime of x changes from negative to positive. Now part B, intervals where we are decreasing and intervals where f is increasing. So we are increasing from 3 to infinity because f of x is greater than 0. We are decreasing on our interval from negative infinity to 0 and from 0 to 3. Notice how I broke that out because at 0, technically we're neither decreasing nor increasing. And that's because f prime of x is less than 0. And I forgot my e. Okay, so now for part C, we need to find where we're concave up and concave down. So part C, I find my second derivative. That's equal to 24x squared minus 48x. I set that equal to 0 and factor out. So our critical points are 0 and 2. So we have 0, we have 2. So again, numbers less than 0, both of those terms are going to be negative, so therefore we're positive. From 0 to 2, the x term would be positive, but that x minus 2 is still going to be negative, so now we're negative. And then from 2 and beyond, we are positive. So we are concave up. From negative infinity to 0, and from 2 to infinity. And we are concave down from 0 to 2. Okay, now part D. This is the hard part, sketching our graph. So I drew my axes in. I'm gonna get some x values in here, making sure you're labeling the scale. You might even want to label that that's the x-axis, and this is our f of x-axis. Okay, they don't give me any function values, but I know from 0 to 3, I'm decreasing, but I have to be constant at 0. So from 0 to 3, I'm decreasing, but from 0 to 1, I'm concave up, and then I change concavity. So I'm concave up, holding water. At 0, I have to be some sort of constant. Then I'm still decreasing all the way to 3, but now I'm concave down. Now I'm concave down. At 2, ooh, I missed my 2. At 2, I apologize. 2 to 3, I'm still decreasing, but I change concavity, so I have to change to concave up. And then at 3, I'm increasing concave up. So it looks something like that. Okay, our next example. We are given the graph of the derivative, and we need to estimate the intervals on which we're increasing, decreasing, and x-coordinates of any extreme values. So, increasing. On what intervals? Now, remember, we're increasing when f prime of x is greater than 0. So this is my derivative. So I'm increasing when this function is above the x-axis. So we're increasing on negative infinity to negative 3. And when else am I above the x-axis? I'm above the x-axis from 0 to 4. Now justify your answer. I've been doing that really all along. But you need to write because f prime of x is greater than 0. Now I'm decreasing. We're decreasing when f prime of x is less than 0 or below the x-axis. So we're decreasing on our interval from negative 3 to 0 and from 4 to infinity. And again, justifying our answer. Because f prime of x is less than 0. All right, now extreme values. We have a max. When our derivative changes from positive to negative. So where does our derivative change from positive to negative? When am I going from a positive number to a negative number? At x equals negative 3, and positive to negative, x equals 4. So we have a relative max at x equals -3 and 4 because f prime of x changes signs from positive to negative. And we're going to have a min. We have a minimum when our derivative changes from negative to positive. F prime of x changes from negative to positive. So where is our graph? The actual values of the graph change from negative to positive. That's at 0. So we have a relative min at x equals 0 because f prime of x changes signs from negative to positive. Okay, our next piece, I give you a bunch of information, and we need to sketch a graph given that information. Okay, first I'm going to draw my axes in. Okay, now what you want to look at everything that you're given. For x is less than 0, we are increasing concave up. F of 0 is 3, so I'm going to put that down. I'm going to label my x-axis, my f of x, and my x. And then I might want to put in some values here. Okay, now for f of 0 is 3, I put that point in, that's going to be key. I'm still increasing, but my second derivative equals 0, so I might change concavity there. That might be a point where I'm going to change concavity, so I need to keep that in mind. From 0 to 2, we're still increasing because our first derivative is positive, but now we're concave down. So I'm going to change from increasing concave up to decreasing to increasing but concave down. F prime of 2 is 0, so I might have a max or a min. And then for x is greater than 2, we are decreasing. So I changed from increasing to decreasing, so we're going to have a maximum there. Okay, so I'm increasing concave up. I'm just going to put a point down that's smaller than the function value that we have at 0. I'm going to be increasing concave up. I'm going to smooth out the curve here in a minute, but increasing concave up. I'm still increasing. My second derivative equals 0, but now I'm concave down. I'm still increasing all the way to 2, but now I'm concave down. That was concave up. Now it's concave down. I think about it again as just the slopes of your tangent lines are decreasing. They're getting closer and closer to 0. Then f prime of 2 is equal to 0, so I'm going to have a max. Now I'm decreasing, still concave down. So I bet you it looks something like that. And then smooth out maybe that piece there. So that would be a good idea of what our curve could look like given all of that information. And that's key that you're able to do that. Okay, in our next example, I give us the graph of the first derivative and the second derivative, and I ask us to graph our function f of x. First, I'm going to label f of x and x, and I'm going to label some points on our axes. Your axes can be different than mine. Really, the x's can't be any different, but your y coordinates can be different than mine, and that's okay. Okay, so I want to know from our first derivative when we're increasing and when we're decreasing. So I'm increasing when our first derivative is greater than 0. First derivative is greater than 0 from negative infinity to negative 2 and from 4 to infinity. And we're decreasing from negative 2 to 4. Our second derivative tells us concavity. We're concave up when our first derivative, our second derivative is greater than 0. So we're concave up from 1 to infinity, and we're concave down from negative infinity to 1. So now it's about plotting the points. Okay, so I'm increasing from negative infinity to negative 2. So, and I'm increasing concave down. So from this point to 2, we're going to be concave down but increasing. Now I'm still concave down, but I start decreasing all the way to 4. So at 1, I change concavity. So I'm going to put a little point. At 1, I'm decreasing to that point but concave down. So decreasing concave down. Then at 1, I change to concave up again, but I'm still decreasing all the way to 4. So I'm going to put some sort of point. It doesn't matter where my y coordinates are. I'm just guessing as to where those are. So now I'm concave up though, so I'm holding water. Concave up, holding water, holding water. My slopes are getting bigger. And then at 4, we change back to increasing. And we look something like that. So that's a general idea of what our curve would look like. That's it for today. There's a lot of information in this lesson. Please make sure your lesson summary is submitted on time.